Beautiful Stone. Wes?
Alright, so my name is Stone, and for my final presentation, I will be taking y'all on a thermodynamic journey of steak. So, here, just a brief outline of what I'm going to talk about. First, figure out what exactly is a cooked steak. Then, the importance of a greasy pan. Some assumptions that go into, your steaks. How you sear it, and then a controversial opinion on potentially a better way to cook steak. Now, so, according to Ruth's Chris, which I don't know if y'all know, pretty reliable source, those temperatures are what you need to get to have a cooked steak, and pretty much it's just getting to a specific internal temperature so that the proteins denature. For this presentation, I'm going to be working around medium rare because medium rare, and so I'm going to be looking at 130 degrees, and those are all in Fahrenheit. If you would go to the next slide. All right, so I just wanted to quickly go over contact and heat flow bounding for two bodies in contact, because that's going to be really important here. So when you look at this, you have your really hot pan and your cold steak. And when they come in contact, they're going to immediately reach some sort of surface equilibrium temperature, and then that is going to be the boundary condition for your steak cooking. And looking at this governing equation, it's mainly just reliant on the thermal conductivity of your beef, which was a really hard number to track down, and of your pan. And as you can see, if you go to the next slide, as you increase your pan temperature, the surface temperature linearly increases, which this is going to be important later, but this is going to have a very large impact on cooking time. And if you'll look to the left, this is with a refrigerated steak versus with just a room temperature steak at the same temperatures, and it honestly doesn't have much of an impact on the surface temperature. All right, so we've all heard about the spherical cow assumption in fluid dynamics. I would like to present y'all with the infinitely wide slab steak. So, pretty much what we're doing here is, unfortunately I put the model on the next slide, but we are assuming that it is 1D heat transfer coming from the surfaces into the center, and that it has no heat losses on the sides, hence infinitely wide slab of steak of uniform material properties. So, if you would go to the next slide. This is our lovely steak model. It's flipped 90 degrees just because that was what I was most comfortable with. But it is at a uniform temperature, the fridge temperature on the inside, and then it has the surface temperature of the pan and steak contact on the walls. And the main differences that are going to occur here as opposed to in the real world when you're cooking a steak is obviously you don't have that temperature input on both sides. So as you flip it, it's going to cool down on the uncooked side, and then that's going to get a little bit less heat rate. And also, your pan is going to drop in temperature because it doesn't have infinite thermal mass. So the contact temperature is going to drop a little bit after you put the steak on initially, but for our purposes here, the infinitely wide slab steak will do just fine. Going on to the next slide. This right here is the temperature distribution inside the steak, and this lovely equation is pretty much just a Fourier transform finding the temperature at all points within the steak. And if you back out temperature and numerically solve for that, you can find the cooking time on each side, because remember, this is assuming cooking from both sides, varies honestly not as much as you would think, but roughly a half a minute to a minute depending on the pan temperature and the steak temperature. So, it's pretty important. And this is the reason why that's important is because you need a long time to develop your crust. And if you cook it at too high of a temperature, then you won't have that long of a time to develop your crust. Continue. All right, now, on to the controversy. As I've said, you need to have a relatively low internal temperature, and then you have your incredibly high surface temperature. So, what people normally do to get a nice juicy rare steak in the interior, but still have a crust on the outside, is cook it at a very low temperature for a long time, and then put it on a hot pan to get the well-cooked center, but then get the crust. However, there's a few problems with that. Mainly, the temperature on the outsides will always be higher than the temperature on the insides because your heating is coming from outside of the steak. So, my solution, have a microwave to uniformly heat it. That way, the hottest point of the steak is on the center, and then it slowly decreases temperature as it goes outward. And then, when you put it on the hot pan, it will spike the temperature on the edges while keeping the center a nice cool 130 for your medium rare. And I believe that is all of my presentation. Any questions? Yes.
What about sous vide?
That is an alternative. It will still be a little bit less optimal in my opinion, because then it's going to be all a uniform temperature as opposed to having a lower temperature on the edges. That way it doesn't overcook. Lewis?
Don't the mechanics of how a microwave cooks things make your steak dry?
It would potentially have an issue of boiling the water within it, which is why I forgot to mention this. You need to cook it on the defrost setting. That way it has a very low heat generation. Yes.
Have you tested this experiment?
No, I am not. I am afraid to.
Okay, that's good.
That's what I'm saying.
It's a microwave steak.
Yes.
Can you go back to your table of contents, like starting where you had the questions you would be answering? Like
Yes.
the very first slide.
The importance of a greasy pan?
Yes.
Yes, I did forget to mention that. So the reason why, if you would go to the skin, this works on the assumption that there is minimal thermal resistance between the pan and the steak. And one way to decrease that thermal resistance is having some sort of fluid to conduct the heat through, which is, as the title says, the importance of a greasy pan.
There you go.
Second.